says determine the equation of the tangent, and when it says tangent, it means tangent line. Okay, it doesn't mean anything else. The equation of the tangent to that curve at the point where that equals that. Would it help you to know what the curve looks like? It probably would help you to know what the curve looks like. So I would suggest when you're doing these problems, you know, graphing, if you don't have a calculator, takes too much time on a test. You could graph it by plotting a couple of points, but if you do have your calculator, and you have that luxury, maybe graph it, and maybe, you know, that would help you. I don't know if it would help you or not, but let's do it. So I got a bunch of junk on here. My window's terrible. I'm going to go back to the normal window, and I'm going to go y equals 2x to the third, make sure you get out of it, plus x squared, and I'm going to graph that. Boy, you can't see my screen, can you? Something like that? Okay. You knew it was a cubic. Now I'm finding it at the point where x equals 2. Is that right? Well, there's 2. So what do you think my gradient's going to look like? Super steep, so big gradient. So the first thing I do when they ask me to find the tangent is, well, this is the gradient of the tangent. The derivative is the gradient of the tangent. Let's write that down. The derivative is the gradient of the tangent. Hey, what do lines look like anyway? What am I even going for here in the equation department? Is that all right? Something like that? Okay, cool. I wish that time display wasn't there, don't you? It's really not good. Is it when you watch the video, is it there? No. No, okay. All right. So I'm going to do that first. I'm going to go dy dx equals 6x squared plus 2x. Now, if that's the m, how is that an m? With all that stuff there. It's not even a number. Remember, we talked about it a long time ago. It's the formula for the m. Right? So I could put any point in on that graph, any x value, and it would give me the gradient at that point. Now, do we know what point we're using? We know x is 2. Do we know what y is? And is that important? Maybe, maybe not. Okay, so let's just put the 2 in. So I'll go at x equals 2, the gradient of the tangent, I use that little notation, I think a lot of people do, equals 6 times 2 squared plus 2 times 2. And I can calculate that in my brain or on a calculator. 28?
Yeah.
Big positive? Yes. Big and positive, I like that. So that's my gradient. How am I going to find that c? Okay, so finding the c stinks. It's a year 10 thing where we go, okay, we'll put in a point and blah, 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 right? Okay, so that's fine to do, but there's another formula that's so much better. I'm going to make it orange. There's a really, really, really better formula. The people that had me, I think I taught it to you, which is y minus y1 equals m times x minus x1. This makes it like I don't really have to find. Thinking I don't want to learn another formula, but it's so worth it. Okay, it's a really good one. So I need a point, x1, y1, and the gradient. So I've got the gradient, 28, and my point is 2 comma something. Right, they gave me 2. That's where the point, that's the only point I know that's on this line. You know, they gave me that. So it's 2 comma something. How do I get the something?
X equals 2.
x equals 2. How do I figure out what the y is?
Sub
Sub into the original, right? That's the y. This is dy dx, right? Original?
Yeah.
Okay. So x equals 2 into original. Because that's what y is. Y, am I off? Y equals 2 bracket 2 cube. What am I doing?
That was just 2
Yeah, no, I'm good. 2 cubed plus 2 squared, which equals, let's see, 8 times 2, 8 is 16, plus 4 is 20. Is that right? All I did was put 2 into the original to get that 20. And by original, I mean up here, right? Original, original. Okay, now I have what I need to use this beautiful equation. So I go y minus 20 equals 28 times x minus 2. And then I go y minus 20 equals 28 minus 56x. Ooh, I didn't want to make a mistake, girls. I was going so well. 28x minus 56, so y equals 28x minus 36. Okay? Now, sometimes, not on this problem, I'm saying something that's not true, but sometimes on problems, they say, and justify your answer. Right? And so justifying my answer probably would be something like this. You know, something really steep. And I might put a thing where there's 2, and then I might draw something and go, you know, this is going to hit really low. It's so steep, 28, that it's going to hit the y-axis really low at negative 36. Okay, so in your mind at least, say to yourself, does this make sense? Because lots of times we get an answer, even with a picture drawn, that says plus 36. And I go, really? You think that line's going to hit the y-axis at 36? That's just not, why did you write that down? You know what I'm saying? So justify in your mind, did I do it right? That is going to